Everybody say hi, Erica.
Hi, Erika.
Hi. We're going to go fast because we're running out of battery on my computer. So we're going to go fast. Okay. Anywho, precision versus accuracy. Okay, there's a difference between being precise and accurate, and people use them interchangeably, but there is a difference between the two. When you are precise, that means you are consistent. But that doesn't necessarily mean you are good. That means accurate. Good is accurate. So you can be consistent, but you can be consistently bad, like serving the ball into the net every single time.
That's
You
me,
are
guys.
precise, but you're not accurate. You're not doing a good job. So you want to be both. The goal is to be both precise and accurate at the same time. And I'm going to show you what that looks like. So precision, consistent, good is accuracy. Yeah? Okay, let's go. I'm going to have you flip over to the back side, and I'm going to show you these little targets right here, and that kind of illustrates very, very good of what accurate versus precise is. So this first bullet point is good and accurate, or excuse me, good and precise. So it's accurate because we're doing a good job, because they're all in the middle of the target, and they're precise because they're all kind of consistent, right? Does that make sense? Good and consistent. We're all in the middle, okay? Here, they're accurate because they're all kind of in the general middle, but they're not precise because they're spread out, right? Okay, so we're not necessarily consistent there, okay? Here we're consistent because they're all kind of close together, but we're not accurate because we're all shooting down in the bottom left corner. It's not in the middle, right? So precise meaning consistent, but not in the middle, good. And this is neither. This is neither accurate nor precise because they're all kind of spread out, and none of them are in the middle, really. Okay, so just because you have one doesn't mean you have the other, right? Accurate, precise don't go together. You can be accurate but not precise, so you can be precise but not accurate, right? Okay, so let's go to the front side, and when we're talking about doing precision versus accuracy, there is a test that we do, and one of them involves calculating the absolute error, ABSOLUTE, error. I'm going to abbreviate that AE. And the relative error tells you whether it is accurate or not. Okay, and I'm going to abbreviate that RE. Okay, so the one that has the least absolute error equals most precise. And the one that has the least relative error is the most accurate. Does that make sense? Okay, this is how we're calculating this. The least absolute error is the most precise. The least relative error is the most accurate. Okay, good? All right. Okay. All right, most precise. We're going to look at absolute error first. Okay, precision refers to a clustering of a group of measurements. We want those measurements to be the same, like around the same area. We want them to be consistent, okay? So what we're doing is we're calculating absolute error, and here's how you calculate absolute error. I'm just going to give you a couple of examples. Let's put them off to the side over here. Let's say we have a measurement that they used 8 centimeters, okay? And if I say 8 centimeters, we're rounding to the nearest centimeter, right? Okay? And what could have happened if we're rounding to the nearest centimeter is half of a centimeter is how much I could be off by, because the number that we could have had on the scale here could have been any number that's less than 8.5 or greater than 7.5, right? Those are all going to round to 8. So in this case, the absolute error would be 0.5 centimeters because we could be off on either side by 0.5 and 0.5. Does that make sense? Okay. Now let's say I would have said like 8.2 centimeters, right? Okay. If it was 8.2 centimeters, then this number, the number that I'm measuring, could have been any number between 8.25 and 8.15. Does that make sense? Any of those numbers within that range, if it's greater than 8.15 or less than 8.25, it's going to round to 8.2. So in that case, what's the absolute error? 0.05 centimeters. Does that make sense?
Yeah.
Okay, so it's always going to be the 0.5 of one more decimal place than it is now. Does that make sense? Okay, let's do one more example. Let's say we have 8.24. Okay, let's say I'm going to go even more precise, and I'm going to say that there's that, all right? This number could have been any number between 8.245 and 8.235. Does that make sense? Okay, so the absolute error in that case is 0.005 centimeters. I'm getting more precise the more number of decimal places I go. Does that make sense?
Yeah.
Okay. All right, let's do one more example that's not a decimal. Last example, let's say I do 8 and let's do 3/4 of an inch. 8 3/4 of an inch. Okay. Now, in this case, if I do 3/4 of an inch, what did I round to? The nearest what? The nearest fourth inch, right? I rounded to the nearest fourth of an inch, okay? So what this measurement could have been, we could be off by, the absolute error would be half of 1/4 of an inch, which means I could be off by 1/8 of an inch. Does that make sense? I could be off by 1/8 of an inch, right? So 1/8 of an inch on either side of 8 3/4 would be 8 7/8 and 8 5/8. Does that make sense? If it's greater than 8 5/8, it's going to round to 8 3/4. If it's less than 8 7/8, it's going to round to 3/4. If it would be more than 8 7/8, if it would be this side, that's going to round to 9 inches, right? And if it's less than this number, that's going to round to 8.5. Does that make sense?
Mm-hmm.
Okay. So any number between those two ranges, the absolute error would be 1/8 of an inch on either side of that. Does that make sense? So when we're dealing with fractions, you just take that fraction and you multiply by 1/2, right? Okay. So let's go here. Absolute error for 6.4 centimeters is going to be, how much are we going to be off on either side by? Like 6.4 would be here. What would the absolute error be? 6.45 and?
6.35.
Okay, so what are we adding and subtracting each time? What's the absolute error? 0.05. That is centimeters. That's the absolute error. It's like what you're adding and subtracting each time. It's always going to be the 0.5 of one more decimal place. Okay, all right. 2 1/4 inches. Here we're rounding to the nearest fourth inch, right? And we already kind of did one like that. We're rounding to the nearest 1/4 inch. So what's the absolute error going to be? 1/8, right? It's half of that. So we multiply by a half. Half of a fourth is 1/8, right? 1/8 of an inch. Okay, and we can, if you want to put that on a number line, you can. Here still 2. That was 2 1/4, 2 1/4. Okay, if I add 1/8 of an inch and subtract 1/8 of an inch, this would be 2 1/8, and this would be 2 3/8. Okay, that's what he kind of looks like. Make sense? Absolute error, we're good kind of on that? Okay,
Yep.
All right. So precision as a measurement, it's usually expressed by the number of significant digits reported. Have we learned sig figs before? I'm going to talk about the difference between 4 centimeters and I'm going to change this to 4.0 centimeters. Okay, we're going to talk about 4 centimeters versus 4.0 centimeters. And a lot of people say that those are the same thing. But if we're looking at from precision standpoint, if we're talking about 4 centimeters, this number could be any number between 4.5 and 3.5, right?
Mm-hmm.
Versus this one, if I put a 0.0 after it, then this number could be only any number between 4.05 and 3.95. Does that make sense? Okay, so if we look at this window right here, like this window right here is a very open window, but here we're getting more consistent, we're more precise because we have a smaller range of values that it could be. So people say 4 centimeters is the same thing as 4.0. Actually, 4.0 is a better representation because it's more precise. I know that that number is actually like more specific, more consistent. Make sense? So there is a difference between the two. Okay, let's talk about sig figs. There is a rule here that says any non-zero digit is always significant. Have you guys had Mr. Moose's class? Yeah. Most of you? Yes? Okay, non-zero digits are always significant. In whole numbers, zeros are significant and they fall between non-zero numbers. So like let's say the number 203. That has 3 sig figs. Versus, let's say I have 230. That has only 2 sig figs. Does this make sense? If it's a 0 on the end of a whole number, it's not significant. Versus this 0 falls in between 2 of them, so it is significant. So there's 3 sig figs there versus only 2. Does that make sense? Mm-hmm. Okay. The next bullet point says that if it's a decimal number greater than or equal to 1, every digit is significant. So like 2.00750. This one would have 6 sig figs, right? Because any ending decimal number, anything that ends in a 0, as long as it's a decimal, would be significant, and these zeros are significant also. But they say, like in this 4th decimal place, if it is a number that's less than 1, like 0.00750, these 3 are no longer significant because they're just being used to place the decimal, right? And these 3 would be significant, so that one only has 3 sig figs, right? Because the 0 on the end is significant, but any of the ones that are spacing the decimal out are not significant. Make sense? That's sig figs for you. Okay? All right, let's do ABCD real quick. Determine the number of significant figures. How many sig figs does A have? 6, because any of the zeros in between are going to be significant. Let's bump down to C. Just 3, because the other 3 are not going to be significant. Okay? B. Oh, I shouldn't have used that example. 3, because the ending 0 is going to be significant, right? Because there is a difference between 0.75 and 0.750, kind of like the 4 and the 4.0. Okay, so this one will have 3. What about D?
6.
Jalen says 9. Are the 2 on the end significant?
7.
Yeah.
Are the 2 on the end significant? Yes. What about these guys? These zeros in the middle?
No.
If they're in between 2 significant ones, these guys are significant, so these are yes also. So we have 9 of them. They're all significant. The zeros in between or the zeros on the end, they're all significant. Yeah? I do have a low battery. Okay, we gotta go fast. Okay, go. Next slide. Last thing is relative error. And to calculate the relative error, we do the absolute error, which was like that 0.5 or the 0.05 or the 0.005. And we take that divided by the actual amount, the expected measure. Okay, so down here we said 23 is the amount that I'm measuring in centimeters. Okay, now here's the deal. 23 is my number, and the absolute error for 23 is 0.5 centimeters, right? Okay, so I could be off by 1/2 of a centimeter, right? But here's my scenario. I'm going to add to this. Let's add to this 51 centimeters. Okay, absolute error for that guy is also going to be 0.5 centimeters, right? Okay, now if I'm measuring something that's 23 centimeters versus measuring something that's 51 centimeters, which one is more of a big deal? Being off by 1/2 of a centimeter when it's 23 centimeters, or being off by 1/2 of a centimeter when it's 51 centimeters?
23.
The 23, right? It's like you only had one job and it's not very big, so you better be pretty close, right? Versus 51, if you're off by 1/2 a centimeter, it's not as big of a deal, okay? Because calculating the relative error for each one, we would take 0.5, which is the absolute error, and I would divide by the actual number. So 0.5 divided by 23 versus 0.5 divided by 51, right? Okay? Okay, 0.5 divided by 23. 0.5 divided by 23 is 0.022. And 0.5 divided by 51 is 0.0098. Okay? So we can see that the error is larger for the 23. This is more of a big deal. This is kind of a big deal if you're off by 0.5. Okay? All right, now this is what happens when we're looking at relative error versus absolute error. I'm going to make kind of a little table here, and we're going to talk about precision versus accuracy, and then we'll be done. Okay? So we have absolute error and we have relative error. Okay? So we said the absolute error for each one of those was just 0.5, right? 0.5 and 0.5. Okay? Now, absolute error tells me about precision. Precision. So what can we say about these? They're the same precision. I am the same amount of preciseness for each one of them. Same precision. Okay? But the relative error for each one of these, we just calculated. This one was 0.022 and this one was 0.0098. Okay? So which one has the least relative error? 51. This one's lower. So we would say that 51 centimeter is more accurate because relative error tells me the accuracy. Okay, I want the least amount of relative error, the least amount of whatever. Okay, 51 is more accurate. Being off by half of a centimeter for 51 is not as big of a deal as being off by half of a centimeter when it's 21 or 23. Make sense? Okay, so when they're asking for which one is more precise, which one is more accurate, make sure you're looking at those guys. Good? Okay. Jake's still ready. Everybody say bye, Erica.
Bye, Erica.